So first of all, what is science? Science is something which tells us or which gives us knowledge of anything that is around us. Okay. The knowledge of whatever is surrounding us, regarding the TV, regarding the laptop, regarding the mobile, regarding the plants, whatever, any object that is surrounding us. Knowing about any object is what we call science, right? Now, this science, for the sake of simplicity, is divided into so many types. But basically of two types. Natural sciences and the other one is social science. Okay, science is broadly classified into natural sciences and social science. Natural sciences, this category, it includes, yes, it includes our physics, it includes chemistry, it includes botany, it also includes zoology. Right? Of course, the botany and zoology are known as bio or biology, right? And of course, in social sciences, we have different varieties, right? Like you all know, there is geography, there is say history, then there is civics, there is economics. So these are the different types of things which we come across in social sciences category, right? Now I think you can see our chemistry here in natural sciences category. So chemistry is of course a branch of natural science, right? See, the point in giving you this information is, I want all of you to know what chemistry is. Because being a chemistry student, you must all know what chemistry is. The first point regarding chemistry is, it's a branch of natural science. Then what does it deal with? What does it deal with? Chemistry actually deals with structure, composition, properties, and transformation of matter. It actually deals with all these things. But the one that is striking is matter. What do you mean by matter? After this, of course, we'll go for structure, composition, properties, and transformation of matter. But first of all, let us see what matter is. Matter is anything. Anything that has definite mass, and occupies some space or some volume. What do you have in your hand? Just put them somewhere. It occupies some space. And of course, it has some weight. Suppose if you have a tab or a mobile in your hand, definitely it will have some mass. It will have some weight. Of course, it occupies some space or volume wherever you put it, right? So it is something which has got definite mass and which occupies some space or volume. Got it? Now, again, a question arises of why? Why is matter occupying volume? Why matter has mass? Because matter is composed of atoms and molecules. Okay. So this matter, is composed of some particles. Let me call them atoms and molecules. Slowly, I'm taking you into chemistry. Yes, we have entered. Matter is composed of atoms and molecules. Of course, molecules which are made up of atoms. Because your matter has atoms and molecules, it has definite mass, specific mass, and it occupies some space or volume. Now come back. See, our chemistry is a branch of natural science which deals with what the structure of that matter is, what the shape of that matter is, and then the composition. What are the things with which it is made up of? If it is made up of, say, atom or molecule, I mean, in what proportion they have been mixed, they have been combined, the composition, the proportion, the ratio. Okay, we'll go for all these things, of course. Then, what are the properties of the matter? What are the physical properties of the matter? Say, for example, the physical properties like melting point, boiling point, density. These are all the physical properties. And what are the chemical properties? The chemical properties of matter are those reactions in which this particular substance is involved. Chemical reaction, right? And of course, the transformation of matter. Yes, you can actually make matter exist in any of the three physical states. For example, solid, liquid, or gaseous. Of course, we have two more states. The fourth one is plasma, and the fifth one is Bose-Einstein condensate. We'll discuss about all those, but for the time being, remember, it actually deals with the structure, composition, properties, and the transformation of matter. Now let us define chemistry in a broader way. Listen to me carefully. What is chemistry? It is a branch of natural sciences which deals with the structure, composition, properties, and transformation of matter from its atomic and the molecular point of view. I mean, from the view of the atoms and from the view of the molecule. So this is quite a broader definition for chemistry. Without knowing what chemistry is, you cannot just get into the other topics of chemistry. So I've given you this clarity on what chemistry is. Hope this is clear. Now, let me tell you that this branch of chemistry, science is, of course, a very big thing. For the sake of clarity, for the sake of understanding, it is further subdivided into natural and social sciences. Natural sciences includes things like physics, chemistry, botany, and zoology, right? And now, even chemistry over a period of time has become wide or a very big branch. And even the complexity is increasing day to day because of the wide scope that it has in a research field. Okay. So for the sake of clarity, for the sake of convenience, for the sake of understanding, this chemistry, is further divided into, of course, many branches. But let us just stick to the main branches of chemistry, like, for example, inorganic chemistry. The second one is organic chemistry. And the last one is physical chemistry. What do you mean by inorganic? Inorganic chemistry is that branch of chemistry which deals with the study of elements and their compounds. Complete information regarding elements. I mean, of course, their properties, the physical and the chemical, and their compounds. Again, the physical and chemical properties of all these compounds. So, the branch of chemistry that deals with the elements and their compounds is inorganic chemistry. Now, coming to organic chemistry. This branch of chemistry, which is very interesting, deals with the study of compounds of carbon. You may get surprised to see this because, there is something called inorganic chemistry, which is already dealing with the elements and their compounds. Is carbon not an element? Yes, it is an element. But compounds of carbon are studied under a separate heading. They are studied under a separate heading because of the peculiar properties or the special properties that it has. Unique properties that it exhibits. What are the peculiar properties of carbon? Let me just give you the details. There is something called catenation. The most important property that is a reason why carbon is able to form millions of compounds. Of course, this number is increasing day to day, is catenation. Catenation is nothing but, in simple terms, I can tell you that it is the self-linkage of identical atoms. Self-linkage. Let me give you this. Carbon with carbon, carbon with carbon, carbon with carbon. Not just in forming the straight chain, but in forming the cyclic ones. It is the ability of an atom to bond successively with itself. To bond successively with itself. To form chains of different lengths and even different shapes. That is what we call catenation. You may get one question in your mind. But why? Why only carbon? Why only carbon can form this kind of chains, this kind of rings? Yes, that's an interesting question to discuss. Because this bond is a stronger one. If suppose there is a bond which is a stronger one, such bonds, in fact, are formed in a large number. If suppose there is a bond between, say, atoms of X, but this bond is not that stable. I mean, if the bond energy of this bond is not that high, then, it is very easy to break the bond. If a particular bond can be broken readily or easily, such bonds can never be formed in larger number. It can never have great catenation. Let me tell you that the bond energy of carbon-carbon bond, which is about, say, 80 kilocalories per mole. This high bond energy of carbon-carbon bond is the reason why carbon is able to form. Carbon is able to link with number of such carbon atoms. In simple terms, I can tell you, suppose if there are, like, say, let me tell you that there are two friends. They are very good friends. They are, say, close friends. And see, when the other people see them, they feel like, oh, see, they are very good friends, and it will be better, it will be good even if we join them, because their bond is a stronger one. People want to join that particular bond. Suppose if there are two friends who are not that good friends, you say something to the guy, to the first guy about the second guy, and if suppose the first guy just goes and hits the second one, I mean, if their bond is not that weak, if the first boy or the first girl or the first guy, yes, somebody has actually, yeah. Now, if suppose the bond is not that strong, you can just say something wrong about the second guy, and if the first guy goes and hits the second guy, I mean, if that is the kind of a bond that they have, nobody will try, nobody will, in fact, have curiosity in joining them. What I would like to say is, if there is a bond which is stronger, such bonds are formed in larger number, which you can see here. Because the bond energy is very high, such bonds are formed in a large number. Got it? So it's simply the self-linkage of identical atoms. Let me tell you that the element with the maximum catenation is, of course, carbon. Next comes silicon, then comes sulfur. Okay, silicon can form bonds even up to 10 silicon atoms or even more also, roundabout. Whereas sulfur can actually combine to about 8 sulfur atoms. I hope you know that sulfur has a crown shape of this type. Look at sulfur, sulfur, sulfur. It's called crown shape or puckered ring structure. Puckered, like this kind of it. Okay, crown shape. You can see 8 sulfur atoms connected with one another. So this is what is catenation is all about. The most important thing, because of which there are millions of carbon compounds, and even this number is increasing day to day. Let me just go for one more thing. The second property that actually is the reason why carbon is able to form millions of compounds is the tetravalency, or let me say, quadricovalence. See, as the name itself suggests, tetra, 4, valency, the combining capacity. I mean, every carbon can actually combine with 4 other atoms. See, these 4 atoms may be carbons also, they may be hydrogens, they may be some heteroatoms, like they may be nitrogens, they may be sulfurs, they may be halogens, they may be oxygens. So these 4 bonds may be with any of these atoms. But remember, every carbon, every single carbon C is able to form 4 strong covalent bonds. I'll tell you what covalent bonds are. Simple. You know, a bond that is formed by the sharing of electrons is covalent bond. You know, every carbon is forming 4 covalent bonds which are strong enough, and see this kind of a structure, this kind of a shape is called tetrahedral shape. So every carbon forms a 4 strong covalent bonds with 4 other atoms. Okay. And even this also is a reason why carbon is able to form millions of compounds. Coming to the third one, you know, it is the ability to form multiple bonds. Yes, even this also is an important one. You know, carbon can even form multiple bonds. Multiple bonds in the sense double bonds, triple bonds with carbon atoms, or even with some heteroatoms, like with oxygen, with nitrogen. But why? You know, for of course, 99.99% of the things we will have answer. We will have reason. Why only carbon? Why not the other? No, I don't say the other atoms cannot form multiple bonds. Yes, even they can form. You can, of course, see nitrogen forming multiple bonds. You can also see oxygen forming multiple bonds, isn't it? Just like the carbon. These are the first elements of their groups. I'll tell you what groups and periods are. But if you are already aware of what groups and periods are, look at the things. Carbon is the first element of 14th group. Nitrogen is the first element of 15th group. Oxygen is the first element of 16th group. Yes, because they are with the smaller size. They can form multiple bonds. See, suppose the atoms are smaller, they can of course have greater hold over the bonded pair, isn't it? Yes, of course. The bonded pair lies more closer to their nuclei. They'll have great hold over the bonded or the shared pair of electrons. This is, of course, a double bond refers to, you know, 2 electrons of this, 2 electrons of this. They are, of course, hold tightly. They are held tightly by the nuclei, by the centers of these atoms. I'll tell you every single point in detail later, but for the time being, remember, if the atoms are small enough, they can actually keep up the shared pair of electrons strongly But otherwise, supposing if the atoms are big, let us take this. They are big. I mean, they are with larger size. And suppose you got a multiple bond. Can they hold this shared pair of electron? No, they cannot, because see, the nucleus is here and there is, of course, greater distance between the nuclei. The nuclei will not have great hold over the bonded pair. So what I would like to say is smaller atoms can form multiple bonds like this. All these are the best examples. See, the smaller atoms can form multiple bonds, but not the larger atoms. Then what the larger atoms will do? Like I just gave you the structure of sulfur. They can form multiple number of single bonds, but not the multiple bonds. Isn't it interesting? They can form multiple or the large number of single bonds, but not multiple bonds. Smaller atoms can form multiple bonds, but not the larger atoms, right? And even this ability to form multiple bonds is the reason why carbon is able to bond, is able to connect with different atoms, right? And one more. See, the last and of course the interesting reason behind the wide variety of compounds formed by carbon is isomerism. You know, iso means the same. Meros means parts. Simply speaking, you will have the same molecular formula, but the same formula, you know, will have different properties. Different properties because of different existences. Let me just give you one example, a basic example. Suppose if there is something with 4 carbons, it can exist this way or it can exist even this way also. There is a difference in chain. The first one has a straight chain, whereas the second one has a branched chain. Now they've got difference in the nature of carbon chain. So we call them chain isomers. Got it? So that's how I have actually got a very interesting discussion. This is a very big topic. I have actually allotted some 17 to 20 classes for isomerism. You can check out the schedule copy. It's a very big topic, but for the time being, remember, isomers are those having the same molecular formula, but differ in their properties. And even because of this also, see, the same molecular formula is existing in different formats, different types, different ways. So, same molecular formula existing in different varieties will also give rise to large variety of compounds. Suppose in a compound with 4 carbons, if you have 2 varieties, then if suppose we consider a carbon compound with say 50 carbons or 100 carbons, how many wide varieties can we expect? So these are all the different reasons why carbon is able to form millions and millions and millions of compounds. So the first one and the most important one is catenation. The second one is the tetravalency or quadricovalency. The third one is the ability to form multiple bonds. And the fourth one is the isomerism. It is because of all these, carbon is able to form millions of compounds. Now let me go for the last variety called physical chemistry. Now this is very interesting. I've been telling you that the matter is composed of atoms and molecules. It will have physical properties, it will have chemical properties. I mean, it will have chemical reactions to undergo. Yes, of course. Chemical compounds, they undergo some varieties, different varieties of chemical reaction. And you know, the knowledge of physical chemistry tells us things like the rate or velocity with which a particular reaction is taking. Let me tell you. See, there are slow reactions like the rusting of iron, you know, rusting of iron. We know that. Suppose if an iron object is placed somewhere outside for months together, if suppose it is placed outside, you know, it gets rust, isn't it? Rust, of course, is a chemical thing, chemical phenomena. It's a chemical phenomenon. It's a very slow reaction. It is a chemical reaction, occurs very slowly. In fact, takes even months to complete. That's a very slow reaction. And there are certain reactions which take place in fraction of a second, within milliseconds, like say 10 power minus 4 seconds minus 3 seconds. For example, the reaction between say silver nitrate and sodium chloride. You know, when these two, I mean the aqueous solutions of these two are added, within 10 power minus 4 seconds, you know, you'll get a precipitate of silver chloride within no time. So this is considered to be the fast reaction. So this is a fast reaction. Then the slow reaction, of course, is rusting of iron. And of course, there are wide varieties. We'll discuss about all of them later. But see, there are reactions which occur with a moderate rate. Okay, most of the chemical reactions which we carry out in laboratory are the reactions which take place with a moderate rate, unlike the fast reactions which take place in fraction of a second, or unlike the slow reactions like the rusting of iron, which of course occurs in months. These are the reactions which we normally carry out in chemical laboratory. They just take place in say 5 minutes, 10 minutes, like that, 15, 20. Not too much, not too high, not too low. Is that okay? So physical chemistry, it actually deals with the rate or velocity of the chemical reaction. And see, it also deals with the factors which influence the reaction. Like for example, what is the effect of changing the temperature on the reaction? What is the effect of changing the pressure? What is the effect of using a catalyst? Like that, there are so many things which affect the yield, the productivity of a reaction. We get, say, suppose there is a reaction which gives you only 30% yield, 30% of the product. Then how to increase the yield or the productivity? How can we increase that to 40% or 50%? Either by changing the temperature or by changing the pressure. I mean, either by increasing or decreasing or using some catalyst. We can, of course, increase the yield of the reaction. Now, all these things put together is your physical chemistry. Physical chemistry is a branch of chemistry that deals with the fundamental principles that are behind every chemical phenomenon. The fundamental principles underlying various chemical phenomena. That is about physical chemistry, right? So inorganic is the one that deals with of course, the study of elements and the compounds. Organic chemistry is something which deals with the compounds of carbon. Physical chemistry is the one that deals with the fundamental principles. There are so many principles like Le Chatelier principle, the law of mass action. There are wide varieties, different varieties which actually give us information about the rates or velocities and the factors and many more things. These all principles are studied under physical chemistry heading. Okay, now after knowing all these things, we should also know who the father of chemistry is. Okay, you know, the father of chemistry is Robert Boyle. Robert Boyle is the father of chemistry. Right? Now, of course, Boyle is considered to be the father of chemistry, but there is Antony Lavoisier.
No, I never.
Antony Lavoisier. Okay. Yes. Antony Lavoisier, who is considered to be the father of modern chemistry. Okay. And then there is somebody from India, Prafulla Chandra Ray. Okay. He is considered to be the father of Indian chemistry. Right. So these are, of course, not at all related to IIT or NEET. But you know, being a chemistry student, you must have the knowledge of all these things, isn't it? Just a minute.